Most humans can see color, but that's only a small part of the spectrum of light, a really small part. Other animals can see other parts of the spectrum as well. Snakes can see in infrared, which allows them to see the light given off by heat. Some birds can see farther into the ultraviolet spectrum. In fact, there's a whole world of light we can't see, not only other wavelengths, but properties not even affected by light's wavelength. I'm talking about polarization. Bees can detect light polarization, which is a property of light that isn't related to its wavelength. It helps them orient in which direction they're moving and acts as another visual point of reference when they're gathering pollen. But if it's not a type of color or a wavelength of light, then it begs the question, what is polarization? Well, to understand that, we'll have to consider what light is in a little more detail. Light is really due to vibration of electrical charges. It's really a little more complicated than that, but for the purposes of understanding light polarization, that's pretty good. The vibration happens in two directions. One vibration is an electric component, the other a magnetic component. And both these components vibrate in a direction perpendicular to the traveling light wave. Most light we're used to isn't polarized. All the vibrations happen in all different directions. We call this light unpolarized. But sometimes the vibrations happen in only particular directions. Polarization of light is defined by the vibration in the electric field. When the vibration of light stays in the same direction, we call it linearly polarized. And when the vibration in the electric field rotates, that light is circularly polarized. But can we move between different states of polarization? As it turns out, yes. This is a polarizing filter. You can see that light is passing through, but not all of the light. That's because the vibration in certain directions is being restricted. Because polarization is dependent on the vibration of electrons, the key is to restrict the vibration of electrons in certain directions. Most polarizing filters are made by dipping long, connected strands of hydrocarbon molecules in iodine. Iodine chains form along the molecules. Electrons move well across these chains, but they don't move well perpendicularly to the strands. This restricts the electron movement, polarizing our light by forcing vibrations in only one direction. We see polarizing filters a lot in everyday life, perhaps more than you'd think. Lots of sunglasses are really polarizing filters, reducing glare you might see on the road while driving or off the water at the beach. When light reflects off a surface, it breaks into a reflected wave that bounces off the surface and a refracted wave that passes through the surface. This split polarizes the vibration of light waves and effectively acts like a polarizer would. Here, check this out. If I take a polarizing filter and I hold it up, I'm polarizing all the light that passes through the filter. Now, if I take another filter, this time at a different angle, watch. None of the light is passing through both the filters. This is what happens to our sunglasses, to the polarized light that's reflecting off the road or off the water. We also see it in most of our phones and computers. Underneath the screen are layers of polarizers and crystal gels that can polarize the light passing through the screen. If we look at the computer without one of the polarizing filters, we see this white light. All of the light is passing through to our eyes, even though some is polarized. But if we throw another filter on, we can see what you normally see on your computer, because we're restricting some of the light passing through. Weird, right? So, our eyes may not be able to tell the difference between polarized and unpolarized light, but we take advantage of it all the time. 3D movies, oil paintings, windshields in cars, all sorts of things. We may not always be able to tell when we're looking at polarized light, but it's all over the place.